Good morning, everyone. I'm Ranger Bekah here at Flathead Lake State Park. Welcome to our virtual Junior Ranger activity. I'm out here on the rocks at Wayfarers, and all I can think about are rocks. Rocks are everywhere. They're the most common material on Earth. There are three types of rocks: igneous, sedimentary, and metamorphic. Igneous rocks form from the cooling and hardening of magma, while sedimentary rocks form when particles of rocks and minerals are combined. Metamorphic rocks form when a rock completely changes from its original form due to heat and extreme pressure. Just like water, rocks go through a cycle as well. There's really no starting point, so let's just start at weathering and erosion and call that stage 1. Rocks are eroded and washed away by wind and water, creating sediment. The accumulated sediment is pressed together to form sedimentary rock. The sedimentary rock is then pressurized and heated and turned into metamorphic rock. The metamorphic rock melts and turns into magma. The magma erupts from a volcano and cools on the Earth's surface to form igneous rock. The history of Flathead Lake goes back 4.6 billion years ago to when the Earth was formed, and it's all about rock. Around 2.7 billion years ago, thick layers of sediment eroded from the rocky continents and were deposited in shallow seas, forming the oldest bedrock in Montana. 125 million years ago, the North American continent was drifting westward from Pangaea. The Rocky Mountains were formed by an uplift of rock material caused by the collision and subduction of the Pacific Oceanic Plate with the North American continent. 40 million years ago, the compressional forces from the plate subduction, which had formed the mountains, let up, and tension in opposite directions caused ranges to split, which form long valleys like the Flathead. 2 million years ago, the Ice Age began. Huge glaciers advanced south from Canada into the Flathead Valley, filling the Rocky Mountain Trench with ice, sometimes 20 miles wide. And just 10,000 years ago, the glaciers started melting rapidly. Though some large masses of stagnant ice survived in the basins of moraines and melted much more slowly. One of the ice masses deposited at the southern end of the Flathead Valley and became Flathead Lake. To better understand these Earth's movements, we need to know the plate tectonic theory. So the plate tectonic theory states that the Earth's surface is covered in 9 large and a few small, slowly moving plates that fit together. These plates ride on the Earth's mantle. Sometimes these plates collide and form mountains, or separate and create rift valleys. We live in a unique geographical location, in a large valley with mountains in every direction. But how did those mountains form? The mountains are composed of uplifted, folded, and faulted sedimentary and metamorphic rock. When two plates converge, the heavier plate will sink beneath the lighter plate, causing the ground to fold and create mountains. To better understand this process, I will show you a plate tectonic activity that you can do at home. For this plate tectonics activity, you will need a dish of water, some graham crackers, a plate, and ice cream or whipped cream. I'm using ice cream. You can also use red food coloring to dye the ice cream or whipped cream to make it look more like magma. The Earth is made up of many layers. The outermost layer is hard and surrounds the Earth like a shell. This is called the crust. Earth's crust is cracked into big pieces called tectonic plates. These plates fit together like a puzzle surrounding the Earth. Under these plates is a layer called the mantle. The mantle can move like a liquid if it gets hot enough and has enough pressure. This causes the big plates of crust to move, and it's the moving of these plates that causes mountains and volcanoes to form. So in this activity, your graham crackers are your tectonic plates, while your ice cream or your whipped cream is the mantle. where the two graham crackers meet is called a plate boundary. They are so named by the way the plates move against each other. So the first plate boundary I'm going to model is our transform boundary. So this type of boundary occurs when two plates grind past each other. So place them in your ice cream. And pay attention to how it feels sliding the graham plates against each other. They grind past each other. At transform boundaries, plates move in opposite directions, slowly grinding past each other and occasionally getting snagged. As pressure builds, the plates finally slip, releasing a jolt of energy that we feel as an earthquake. Another type of boundary is a divergent boundary. Divergent boundaries occur when two plates move away from each other. So set your grams in the middle, and you're gonna push down and pull your grams apart. The mantle oozes up between the plates. Did you see that? So I'll do it again. So it oozes up between the plates. Most active divergent boundaries occur where two oceanic plates are moving far away from each other, and hot magma flows up where the plates separate, forming large underwater lava flows and creating new seafloor and even volcanic islands. Convergent boundaries occur when two plates move toward each other. When two plates move toward each other, they can either collide, forming mountains, or one can slide under the other at the subduction zone. To model forming mountains, dip one end of each graham cracker in the water. So it looks like this. Each end I've dipped in water. Place the soggy ends facing each other and push them together. Whoop. The soft grams fold up and mountains are formed. When two plates are converging together, a subduction zone can occur. Subduction zones occur when two plates move toward each other and the denser one slides under the less dense one. So push your gram plates together and slide one underneath the other. This is a subduction zone. These tectonic movements have occurred over millions of years, shaping the landscape as you see it today. Thank you for joining me for Rocks Rock! Junior Ranger activity at Flathead Lake State Park.